स्टूडेंट्स सॉलिड स्टेट फिजिक्स 1 का टॉपिक है हमारे पास सरफेस imperfections. Surface defects are the two-dimensional regions in a crystal. They arise from a change in the stacking of atomic planes on or across a boundary. They are of the following two types: external defects, internal defects. External defects. The external type is just what its name implies, the defects or imperfection represented by a boundary. The external surface of the material is an imperfection itself because the atomic bonds do not extend beyond it. The surface atoms have neighbors on one side only, while atoms inside the crystal have neighbors on either side of them. Since these surface atoms are not entirely surrounded by others, they possess higher energy than those of internal atoms. The energy of surface atoms for most metals is of the order of 1 joule per meter square. Internal defects. These defects are discussed below. Grain boundaries. Grain boundaries are those imperfections which separate crystals or grains of different orientations in polycrystalline aggregation during nucleation or crystallization. In materials like copper, there may be crystals of various orientations. These individual crystals are called grains. In one grain, atoms are arranged with one orientation and one pattern. However, there is a transition zone between two adjacent grains which are not aligned with other grain. As shown in Fig 6.3, various degrees of crystallographic misalignment between adjacent grains are possible. When this orientation mismatch is slight on the order of a few degrees, then the term small or low angle grain boundaries is used. In the boundary where the crystals or grains change abruptly and orientation difference between neighboring grains is more than 10 to 15, the boundaries are known as high-angle grain boundaries. The mismatch of the orientation of adjacent grain produces a less efficient packing of the atoms at the boundary. Thus, the atoms along the boundary have a higher energy than those within the grains. The boundary between two crystals which have different crystalline arrangements or different composition is called an interface boundary or an interface. Tilt boundary. Tilt boundary is a series of aligned dislocations which tend to anchor dislocation movements, normally contributing to plastic deformation. Little energy is associated with this type of boundary. This is called low-angle boundary. Fig 6.4, as the orientation difference between two neighboring crystals is less than 10 degrees. A low-angle tilt boundary is composed of edge dislocation lying above the other in the boundary. The angle of tilt theta is equal to B over D, where B is the magnitude of the Berger vector and D is the average vertical distance between dislocation. नेक्स्ट हम पढ़ेंगे अपनी नेक्स्ट वीडियो में. हमारे चैनल को सब्सक्राइब कीजिए ताकि हमारी आने वाली हर वीडियो आपको आसानी से मिल सके. थैंक यू.